I'm going to be talking to Chris Bataille, an energy economist we interview regularly here at Energy Media, and we're going to be talking about the decarbonization, the rollout of electric technologies in industry. This is supposed to be the hardest sector to abate, the hardest sector to electrify, but we've made great strides in the last few years. Welcome to the interview, Chris.
Hey, Markham, it's great to be here. Thank you.
Well, I know this is an area of particular interest for you. It's a research interest and you publish on it. Give us the sort of 35,000-foot view. Where are we at now with the electrification of industry?
Yeah, that's an excellent question. To start with, everything is electrifiable eventually, right? Like electricity is just an easier form of energy to work with. You could do exactly the work you want to do, moving molecules around, moving heat around, what have you. The reason we didn't start with electricity is, we started with coal and just started moving things around with steam engines, what have you. And then along came gas. And if you go back far enough, you go back to wood and whale oil and all sorts of things. But the natural progress through time is to electrify more and more things, just because it's a more efficient energy form to use. The question is, it has to be cheap. Electricity tends to be more expensive than coal, more expensive than gas. It's all about what we call the spark spread between gas and electricity. If electricity's, gas is expensive enough and electricity is cheap enough, there's a lot of technologies we already have, like industrial size heat pumps, direct induction heating, what have you. Most things are electrifiable even today. There's not a lot of processes you can't electrify with existing technology. It's just the cost.
So does that suggest that as wind and solar become more efficient, paired with batteries, and more abundant, I guess we're seeing negative prices where wind and solar are plentiful in those kind of markets. So does that mean that as the wind and solar and other energy technologies roll out, that then supports the electrification of industry?
To a certain extent, some places have cheaper wind and solar than others, right? Like if you're in the middle of Australia or the Middle East or North Africa or near the Southwest US, it's just going to be cheaper in terms of solar. Wind is much cheaper in some places, and we've all heard the debates about when it's plentiful, the price falls. When there's not enough of it, the price rises. And can you build a business model off of that, right? Because most industrial technologies are designed to run 24/7 with some downtime for maintenance, right? So if you're paying a lot at nighttime, is it worth it? Should you just stay on gas or coal if you're not trying to factor in carbon pricing? Batteries are going to be hard because a lot of industrial processes use a lot of raw energy, right? Like just to melt a ton of steel is somewhere around 500 kilowatt hours. That's what it, or a theoretical minimum is 300 kilowatt hours. And that's 30 days for most households of electricity, just to melt 1 ton of steel. So the raw energy needs are very high. But if you add wind, you add solar, you add batteries, you add some transmission from different regions, you have a little bit of firm energy, like you have nuclear, a little bit of, some fossil fuels with CCS, deep geothermal eventually, it should be viable to electrify most industries.
Well, let's talk about the three types of heat that's required by industry: low temperature, medium temperature, and high. My understanding is that industrial heat pumps are pretty good at low temperature heat below 100 C.
Yes, no, they've been commercially viable for 20 years, right? It's just building up the industry and the amount of volume. It's the ones that go over 100 and give you steam are the real deal breakers, because that opens up about 30% of the industrial heat market.
So what about let's talk about some of the applications for low temperature. So that would be food and drink, pulp and paper, light industry, those, what else, what other industries might use
Here,
low temperature heat?
here's the one that might surprise people: the oil and gas industry. It uses a lot of low 50 to 100 C heat just to keep everything warm, to separate fractions, what have you, keeping batteries warm, what have you. It's actually one of the areas where, in a place like Alberta, which has got really decent wind and solar, one of the first applications of large industrial heat pumps, it could be ground source air source, could be in the oil and gas sector.
Now, what about medium temperature, which is 100 to 400 C? What are we talking about there?
Most of that's the chemical sector, chemicals, textiles, chemical production, what have you, tends to be quite concentrated. It's a little bit harder because of just that raw amount of electricity you need. You need a lot of generation, a lot of transmission to do that. What you could be doing though is, and this is one of my areas of research, is most industrial sectors have some raw commodity that you're transforming in a couple of different stages up into the thing that's useful to you. What you could do is site your industrial facilities where the raw resource is. It could be iron ore for iron. It could be, whatever you want to make hydrogen, whatever you want to make hydrogen out of for ammonia. But you place those facilities in a place with really good sun or really good wind, and then they can make it as cheaply as possible. And then you ship that intermediate commodity to Europe, to the eastern seaboard of the States, to China for processing up into the final commodity, which actually isn't anywhere near as energy intense. But that implies a different global industrial structure of traded commodities from what we have today. But it's quite feasible. We just need long-term consistent signals that this is what we want to do.
But that sounds like a model that might apply to Canada because we do a lot of mining here. We have a lot of minerals and we
Mhm.
tend to ship it out raw. Is that a strategy that the federal government could use as part of its nation building, to add value to minerals by, taking advantage of our clean power grid and our low electricity prices?
No, absolutely. One of the projects I've been working on, we're actually one of the top 5 producers of of iron ore, period, and one of the top producers of high quality iron ore here in Canada, mainly from the borderlands between Quebec and Labrador. That's taken out of the ground, put on a railway, sent down to the port of Sept-Îles, and then it's shipped around the world. But that area has amazing wind resources, and it already has Hydro-Quebec's transmission system in there. Quite easily, we could be making the necessary raw energy needed to make a hydrogen, which can be used to reduce the iron ore down to elemental iron, which is the most GHG intense step. And then you do that, you make what's called hot briquetted transportable iron, you compress it, and then you send it down the railway to Sept-Îles. You can send it to Ontario, you can make it steel from it, you could send it across to Europe, and they could make steel from it. But that's one area, and that same sort of clean metallurgy could be applied to several sectors across the country.
Okay, let's use your example of the iron ore. Why aren't we doing it?
Partly it's just the time and place where we are right now. You've got a huge oversupply of steel from China. The oversupply from China is about 10 to 15 times the total amount of steel that we make in Canada, right? Like, it's just, the scale of it is enormous, right? Like, they built up a huge production fleet to build all their buildings, infrastructure, machinery, what have you. They just don't need all that production capacity anymore, but it's dumping steel onto global markets, and it's just making it very hard to make these kind of clean investments, right? Until we can sort out that huge bubble of overcapacity in the global markets. And they've done the same thing with clinker and a lot of chemical products and what have you. It's an endemic thing across industry.
Okay, so that's the steel industry. Are there other industries, and say minerals, where we could say we're going to take clean electricity at a low cost and we're going to smelt and refine those minerals before we send them off to global markets?
Quite possibly. Like I said, most of the commercially developed processes are heat driven, but they can easily be electrically driven, right? So almost most metallurgy of one sort or another, what you can do is you grind up the metal and then you put it in an acid bath of some sort, and then you can extract the metals using, like, you inject electrons using electricity and pull off and that's going to be the next wave of how we do steel eventually, a direct electrolysis of steel. But we're probably going to be able to do that with several different metals. And we're going to be able to use different kind of acid hydrometallurgy is what this is called. We use it to extract lithium. We use all sorts of different metals at that point in time. But the steel one is the one we're most advanced with. The one I would hope we do is fertilizer production. Right, most fertilizers it's made from hydrogen. We take the hydrogen out of natural gas today, and then we make ammonia from it, make urea, and that's where most of our fertilizers come from. But you can make hydrogen by splitting water and then create your urea and your fertilizers. And it's quite conceivable across this country. Our fertilizer plants could be converted to basically electrified.
Is there any movement? And I guess part of the reason for asking the question, Chris, is we're kind of at an inflection point in Canada's history. We've decided, under Prime Minister Mark Carney, that we're not going to integrate the Canadian economy with the American economy any further. We're going to look for new trading partners in Asia and Europe. We're going to build out big infrastructure, big projects to advance that strategy. And it seems like if you're going to do that, at this moment in time, electrifying processes that add value to natural resources seems just like a logical thing. Is that a good argument or not?
I think it's a good argument, but we have to be careful not to get too far ahead of ourselves. Like, we have to do one profitable thing, then another profitable thing, then another profitable thing. And the iron is one I focus on because it is profit. There are people out there willing to pay a whole lot more for green iron than they are for dirty iron to make steel, right? The same will be seen for fertilizers, for cement. There are lots of really high value chemicals where you mix a mixture of electrical processes and biological processes to get ethylene, to get all the various chemicals that we make the stuff all around us out of. This is all stuff we already know how to do at the sort of the room scale reactor level and slightly larger. But getting to you have to create markets for these things. You have to get to the point where people are willing to pay for them, pay the extra cost. Now, what's very important to understand is all these things are quite doable. Like the engineering exists, but they tend to raise the cost for the producers somewhere between 20 to 200%, right? It costs nothing on a macroeconomic scale. Like, it won't cost the final consumer a whole lot for green steel, for green cement, for green ammonia, for green plastics. It won't cost, like, the stuff that I consume or you consume. It'll add nothing. It's the value of a few cups of coffee to us, right? But it's enough to bankrupt the producers if they can't if they don't get that necessary green premium. Now, a lot of my research focuses on how do you connect that very low cost to final consumers to the very high cost for producers? Can you somehow create used market forces to connect those to direct contracting, creating markets around clean commodities, what have you? And that's going to be the work of a couple of generations, is my guess.
Chris, okay, so let's assume that's the case. This is we're not ready yet to do everything. Fair enough. But is this an area where Canada could, expand its expertise, develop new expertise, put money into research and development, become a leader in it, so that we see clean electricity as a impetus to diversify the economy?
Yes. We have to stop seeing, and you and I have had conversations about this before, stop seeing ourselves as sort of bulk producers of products that we then ship and other people turn into valuable things. The only way we're going to keep raising wages and making profits in this country, lifting everyone's at our economic development level, is if we make premium products, and we make premium green products that are connected through to consumers that are willing to pay for it. Like, we need to establish trading relationships. A lot of these markets are going to be in Europe. They might be in Japan and Korea, with the Australians and other countries that that can move on to these green markets and then expand more broadly. And don't be surprised if China within 10 years is using all its engineering talent and its fast moving industrial policy to leapfrog to that level. They leapfrogged in terms of power production, they leapfrogged in terms of EVs and batteries. Don't be surprised if they jump to where they're creating a supply and demand for these clean commodities and clean engineering. We have to stop thinking bulk commodity. We have to think high value, clean, that produces high value services to consumers.
Is it fair then to say, because I've interviewed other economists and they say that the quickest way to create economic development is to add value to resources. And you and I have had these conversations about what Canada needs to do is get up the value chain. Mm-hmm. Right now we're at the bottom. We're sending out raw materials, raw minerals, raw timber, raw oil and gas, and we need to get up the value chain. Do we have a strategy in this country to do that?
I have not. I am sure the discussion exists, but it's not on a public level, right? So you with big strategies like what you're talking about, you start from where you are, right? We have the economic structure we have today, the exports we have today, which is how we earn US dollars and other foreign currencies to buy what we need. But you need a vision going out, 10, 20, 30, 40 years, where you want your society to evolve to. What products are you providing to the world that you can do cheaper than better than anyone else, that people will buy from you, and that's how you make your way in the world. And we need a notion of these stepping stones to, in my area, be clean steel, clean cement, clean petrochemicals, other industrial products, and this is all this, and then all those chemicals, what have you, is what we make batteries out of. It's what we make, the fabric of our civilization out of. We need a notion of how we're going to climb that ladder and traverse the stepping stones from where we are today to where we're going.
That it seems like, given where we're at, and I referenced this earlier, but it seems like now is the time. I mean, yeah. It's not very often that the stars align to change the political conversation around energy and the economy in Canada, but they certainly, thanks to Donald Trump, have done that. We're now, and yet, for instance, when we see the 32 projects there was an internal memo from the government that was leaked, and these 32 nation building projects that are up for consideration, and a lot of them were just sort of the same old, just more of it to different customers. And instead of having the kind of conversation that you're suggesting we need to have.
Yeah, and we have to be willing, like, we've come out of an era where free trade almost for its own sake was the name of the day. Now we have to think about, where does free trade serve and not serve, right? The high-speed rail is an example in there. It wouldn't cost much, and I've done the calculations for the British government, right? Like, they had all these high-speed rail projects that they were talking about over the last decade. It adds almost nothing to make it out of green steel. Almost nothing, right? If we made the HSR from Quebec City to Windsor or whatever it's going to be, and we prioritize green steel in there, that would make the market, and it would add almost nothing. Like, the vast majority of the costs in that project are going to be land purchase and labor and what have you. The commodities to build it, almost nothing. You could use green concrete, you could use green steel, green other metals, and you'd prioritize Canadian suppliers. You could literally anchor a clean industrial revolution just out of the HSR in Ontario and Quebec. Right now, think of it, and we only $5 billion was applied to transmission. We could the 30-odd billion that went into TMX could have built us a world-class east-west grid that would also serve our sales to the Americans, but allow us to transfer clean power between BC and Alberta, between the hydro dams and the wind and solar, between Quebec and Ontario. It could have allowed Saskatchewan to do something different than just refurbishing its coal plants. It could have been better connected to Manitoba Hydro, right? So it's integrating all these bits and pieces with the same amounts of money.
The Prime Minister has hinted that there's going to be a development strategy attached to whatever comes out of these projects. And what I'm hearing you say is that as we decide upon these projects of national interest, that at the same time we should be looking backward, the backward linkages, which are the inputs into those projects, and saying, could we build a clean steel industry by supplying clean steel to these projects? And high-speed
Yes.
rail would be one. And do you see evidence that we're beginning to think strategically like that?
That's an excellent question. We're having different conversations since last March. We're having different conversations here in Canada. Some of the same conversations, that the repeats of what we've been doing for 30 years, but there is some difference. It's not reflected in official policy yet, but again, I'm willing to give the benefit of doubt that the government is trying to do some really hard things in a very tense time, for all the reasons that we could discuss ad nauseum. But we do need to start thinking much more. We're never going to be China with like rolling 5-year plans and a 20-year vision of where we're going. But we do need like an updatable vision of how we'd like our society to develop. And that is that we've done this before. The great leaps in Canadian industrialization happened. There was the big, getting agricultural industrialization going. Then the industrialization around World War I and World War II, and then the big build out of infrastructure afterwards. This would just be like the 4th or 5th sort of Canadian industrial revolution.
So we've done this before. We know we can do it. The question is, we need to have some vision, and we need to have the leadership that puts that vision into policy. Correct?
Yep. Yep.
On that note, now that we've solved Canada's problems, this has been a great conversation, Chris. Thank you very much for this.
My pleasure as always, Mark. Anytime.